When r is equal to r1, the volume is the maximum. That is when dv dr is equal to 0. So let's first try to find dv dr. dv dr by applying the product rule, where it is going to be 1 over 3 pi r square. I'm going to differentiate this. This is equal to half of 16 minus r squared to the power of minus half of minus 2r plus 2. Okay, then I'm going to differentiate this, which is going to be 2 over 3 pi r of square root of 16 minus r squared plus 2r. With this, I can simplify. This is 1 over 3 pi r squared. With this is 2, and this will give me a minus r over square root of 16 minus r squared plus 2 over 3 pi r square root of 16 minus r squared plus 2r. Okay, so when r is equal to r1, dv dr is equal to 0. When r is equal to r1, okay, the volume is the maximum, so dv dr is equal to 0, which means that 1 over 3 pi r1 square of 2 minus r1 divided by square root of 16 minus r1 square plus 2 over 3 pi r1 square root of 16 minus r1 square plus 2r1. This is equal to 0. We need to manipulate this so that we can get the equation that the question wants us to show, and that will show us that r1 satisfy that equation. Okay, so looking at that equation, there's no pi, which means that I'm going to, as much as possible, remove pi, which I can because I can divide throughout by 1 over 3 pi r1. Okay, because I know that r1 is definitely not going to be 0, so dividing it, it is totally fine. So this divided by 1 over 3 pi r1 will leave me with a r1 of 2 minus r1 over square root of 16 minus r1 square plus this divided by 1 over 3 pi r1 is going to be 2 of square root of 16 minus r1 square plus 2r1. This is equal to 0. Well, let's try to multiply this in. So it is 2r1 minus away r1 square divided by square root of 16 minus r1 square plus 2 square root of 16 minus r1 square plus 4r1. This is equal to 0. Okay, let me bring the square root stuff over to the right hand side. Okay, so what I have here is 6r1. This is going to be equal to, bring the rest over to the other side, r1 square divided by square root of 16 minus r1 square minus away 2 square root of 16 minus r1 square. Okay, I need to remove this square root or else I will not be able to get the polynomial that the question is asking us for. So I'm going to try to multiply throughout by square root of 16 minus r1 square. So multiplying this over, this is going to be 6r1 square root of 16 minus r1 square. This is equal to r1 square minus 2. This multiplied by 16 minus r1 square square root. This will give me just a 16 minus r1 square. And let's simplify this a bit. So on the right hand side, if I were to simplify this, multiplying the term in, it is going to be, multiplying the 2 in, it will be r1 square minus away 32 plus r1 square. Okay, that is why 6r1 square root of 16 minus r1 square. This will be equal to this, there's a 2 here. So this is going to be 3r1 square minus away 32. And now we are just a few more steps from removing away the square root. What I'll do next is to square both sides. which means that on the left hand side, squaring the left hand side, it will give me a 36r1 square of 16 minus r1 square. This is going to be equal to this square, so 3r1 square minus 32 square. On the left hand side, 36r1 square of 16 minus r1 square. With this, if I were to square it and expand it, it is going to be equal to 9r1 to the power of 4 minus 192r1 square plus 1024. I'm going to bring everything over to the right hand side. It is going to get me a 9r1 square minus 192r1 square plus 1024, which is this, minus away 576r1 square plus 36r1 to the power of 4 is equal to 0. And simplifying this, I will get 45r1 to the power of 4 and minus 768r1 to the power of 2 plus 1024. This is equal to 0, and this is what the question wants us to show.